The number of stars we can see in the sky is surprisingly small, given our galaxy's enormous size. Because of that, many people wonder, why don't we see stars exploding all the time? It's a fair question for anyone who's fascinated by the sky. But now there's a reason to be excited. We may soon witness a rare kind of stellar explosion that could happen at any moment, according to astronomers. Forget Betelgeuse for a moment. Today's spotlight is on the star T Coronae Borealis. Today, in the space world, we'll find out why this system seems ready to erupt at any time. Back when there was no artificial lighting, the darkness of night let people see even faint events. Such phenomena shaped astronomy, fueling the curiosity of ancient observers who watched certain regions of the sky suddenly become extraordinarily bright. In some cases, these outbursts could match the brightness of the full moon and, in extreme cases, even be spotted during the day. However, actually seeing supernovae with the naked eye is rare for several reasons. First, the supernova rate in our Milky Way is fairly low, around 2 or 3 every century. As an example, the last supernova observed without telescopes was Kepler's supernova in 1604. While clues suggest other stellar explosions have happened in our galaxy since then, many of them weren't visible to the naked eye, mainly because interstellar dust can block our view. Sometimes a supernova occurs in a dusty region of the galaxy, making it invisible from Earth. Those areas are called avoidance zones because they appear devoid of galaxies, though it's really just the dust of the Milky Way obscuring them. Any explosion on the far side of our galaxy or in a heavily dusty spot likely wouldn't be seen from here. Meanwhile, those supernovae in nearby galaxies can be picked up by telescopes. They rarely show up to the naked eye because they're so distant and dim. On the other hand, supernovae are recorded across the universe fairly often. A memorable case was in the Cigar Galaxy. In January 2014, supernova SN 2014J was spotted there, shining brightly amid that galaxy's glow. The Hubble Space Telescope captured detailed shots of both the explosion and its shockwave. Time-lapse views from those observations highlighted the size and force of this astronomical event, a textbook example of a supernova, which marks the end of a massive star's life. Once nuclear fusion can't offset gravity anymore, the star's core collapses, flinging its outer layers outward in a dramatic blast. For such a cosmic detonation to happen, the star needs at least 8 times the sun's mass. Only stars that big have the right conditions for this kind of fiery transformation. At its peak, a supernova's brightness can outshine billions of suns, briefly ranking it among the brightest objects in the universe. However, there are several types of supernova, and not all result from a huge star's collapse. Some happen in binary systems, where a white dwarf pulls material from a companion star until it reaches a critical threshold and explodes. This is what's going on with T Coronae Borealis, except it's actually what astronomers call a nova, not a supernova. The possibility of this event happening at any time has observers worldwide on alert, since the last recorded eruption was in 1946. Over 80 years have gone by, and many people thought the nova would flare up last year, but it never did. That means it might happen at any moment. T Coronae Borealis is about 3,000 light-years away and has periodic outbursts, so telescopes everywhere are focused on it to capture and analyze this rare event. Its transformation should be spectacular. Right now, the star's brightness is around magnitude 10, making it invisible to the naked eye. But when the explosion occurs, it's expected to hit magnitude 2, which is as bright as some of the more striking stars in the sky. This will be a unique chance to watch a star system that usually goes unnoticed, but will, for a short time, become a sky-high headliner. So what actually causes this eruption? T Coronae Borealis is made up of a white dwarf and a red giant. The white dwarf, which is the dense core left after a star burns its fuel, siphons material from the red giant via an accretion disk. As that gas and dust build up on the white dwarf's surface, the temperature soars until a fierce thermonuclear reaction is triggered. The energy from that flash makes the star shine far more brightly than usual. Unlike a supernova, in which the star is totally destroyed, a nova leaves the white dwarf intact, allowing the accretion cycle to begin again after the light fades. That means we can guess, up to a point, when the next eruption will be, though we're never 100% sure. Many expected T Coronae Borealis to explode in September 2024, but since it didn't, it could happen any night now. For those eager to keep track, Look for the constellation Coronae Borealis, positioned between Vega and Arcturus. Pausing a sky map or star app can help pinpoint the area and use those two stars as references. Once the eruption happens, T Coronae Borealis will be easy to spot with the naked eye for several days. Even after its brightness drops, binoculars will still let you see it for a while longer, delivering a memorable show for anyone watching the sky. All we can do is keep our eyes on the heavens until T Coronae Borealis puts on the grand display that everyone has been anticipating, blazing a unique light into the records of modern astronomy. It might still take a while, or it might burst forth suddenly, surprising even the experts. For those who love the universe, witnessing the sudden appearance of a stellar explosion feels almost magical, like a front-row seat to both the creative and destructive forces of the cosmos. It's a rare happening, but when it does take place, it reminds us that, despite the vastness of space, there are still secrets waiting to be revealed at any moment. If you enjoyed this video, please leave a like. It's very important. And if you haven't subscribed to the channel yet, I invite you to click the subscribe button below. Thanks for watching, and see you in the next video.